Hi, welcome to UNIX Academy. This is Jyoti. In this video, I am going to explaining Python introduction. First of all, who should learn Python? If you are a CBSE student, you are having a syllabus of Python in your syllabus. Python is a subject in your syllabus. You can learn Python. If you are a fresher to IT field, you can start with your career with Python programming language. Or if you have 8 years experience in IT, you can learn Python. Let's start the Python. Computers and programmers do not understand each other. Programmers and computers talk in totally different language. Make sense? The programmer write programs in a specific programming language code such as Python, C, C++, Java, etc. But computers cannot directly understand what the programmers have written because computers understand a total different language called programming, no, sorry, mission language. This is called mission language. Thus, for a computer to execute your program, it is important that your program code written in some programming language must be converted into computer understandable code, that is mission code. When when a programmer writes a program in any programming language, it is called source code. A source code is written as per some programming language rules, and it is easier for us, means humans or programmers, to read and understand it. For a computer to understand a program, it must be converted to computer's language, which is binary code. I think everybody heard binary. The language of computer is binary language, the language of ones and zeros. This is called binary. For your program to execute, it must be converted into binary code, also known as mission code or mission language code. There are three names, is they don't confuse it. Mission code or mission language code or binary code, these are same thing. But modern mission codes are not just binary code, but they have also have other low level elements such as hexadecimal codes and addresses, etc. Hexadecimal codes base is 16, binary code base is only 2, decimal is 8, 10, and octal 8. This type of codes everybody knows. I am thinking a program converted in mission code can be directly executed by the computer. So broadly we can say that a programmer creates a program, their source code, which needs to be converted into binary by some special type of software so that computer can execute it. The special software the that translate a source code into mission understandable form as the translator software, or is simply the translators. There are broadly two types of translators. One is compiler and the second one is interpreter. The job of both these translator is to convert source code into mission understandable code that the computer can execute. Now come to the point of a compiler. There are mainly two types of translators, compiler and interpreter, that convert source code into mission code but in different ways. The working pattern of a compiler is very different from interpreter. Compilation process. The compiler takes the source code and then follows certain micro steps. Micro steps to produce a low level code. The major step in compilation process or pre-processing, compilation, analysis, and synthesis, and assembly, linking. First, we will see pre-processing. What is pre-processing? What will happen in this phase? Pre-processing. Pre-processing phase removes the extras. This is called comments. Means extras from source code and adds that the any modules uh, required modules, it will add to that source code. You can say added or expanded through by importing those requirements. Modules are coming with the software. Modules imported from there in the program, using import command, and added to that code during in this phase. At the end of this phase, the source code is converted to just the complete code. That means all comments are removed and nothing yet to be added or expanded as a modules imported. Next, second phase is compilation phase. The compilation phase can be further subdivided into two subphases. One is analysis phase, and this is called the uh, front end phase, and the second one is the synthesis phase or back end phase. First, we'll see analysis phase. In this phase, the compiler identifies all the individual units, means keyboards, variables, etc. of the source code and their requirements. Using this information, the compiler creates a special type of table called the symbol table that is useful for determining memory requirements. Memory is needed to execute the source code. Our code to run to execute. Memory requirement is important. Memory is situated in our OS, not in software. It will mingled with OS after compilation of the code. At a time, memory will use this source code. Next phase is this analysis phase is called sub front end phase of compilation. Second phase, synthesis phase, the back end phase. The back end phase of the compiler parses the code and generates a syntax tree, analyzing the syntax of source code. This is two phases regarding to compilation phase. During both these phases of compilation, if the syntax or semantic rules of the programming language are found violation in source code, the compiler generates an error with the line number of the source code. At the end of compilation, all the errors found in the source code with line numbers are listed with line numbers. Programmers can correct the errors and recompile the corrected code. That is, first two phases of compilation process are repeated. Once the changes is required or a programmer changed the code, then again go to recompilation process one for pre-processing phase, then compilation phase, that is analysis phase and synthesis phase will happen every time. Once a lot of times errors will occur, Those errors will rectify the programmer and recompile that code every time. This type of work will happen lot of times in the program. After once all the errors is completed, once error free code will generate. In that free code will go to next phase, that is in this phase, this is called after error free, this is called the intermediate code. The compiler converts into intermediate code, that is in the form of assembly level instructions. First phase completion, the compile the source code converted into just completed code. In the second phase completed, after that it will convert into the intermediate code. Here next step is next phase, assembly phase. This phase receives the assembly level instructions and then converts it into object code, which is a form of mission code. This phase does the same work that an assembler does, converts assembly code to binary code. Next phase is linking. This phase all the required libraries are linked with the object. Libraries are stored in our libraries are coming with software. Those libraries this program will use. In this phase, with the help of OS, all memory references are resolved. I said already, memory is situated in OS. Those memory references are resolved. Why we are using a memory, this program executable code, which is object code or mission code, that is situated in memory, that is stored in memory. So memory reference is always required to translate the programming code into converting mission understandable converting code. Then code is converted to form with required nothing else to run. It has everything in it to execute itself. No need human interaction in this space after the linking. That is, the code has become executable. Now the execution will go with .ext file. Then next phase, loader. The loader is a part of compiler that loads the computer executable module into memory for execution. Compiler now is also not needed to run the executable file. Next, compiler works on the whole program. It converts all the lines of the code into object code in one go and then to executable code. If there is any error, even only at the last line of code, the compiler won't proceed to the next phase until the whole code is error free. There are mainly compiled languages such that C, C++, C hash, Scala, etc. There are uh, many interpreted languages such as Python, Perl, PHP, etc. The interpretation process. The in this process, how it will work. Since an interpreter is also a translator software like a compiler, its role is to convert the source code into mission intelligible code. Through this purpose, it is the same as compiler. Its works is very different from compiler. Unlike compiler, which works with whole program at all steps, the interpreter focuses on one line of code or one unit of code at the time. The interpreter analyzes one line of code, convert into object code, adds in required libraries if any, and runs it. The first line of code is executed even before the second line code is converted to object code. This way, the interpreter proceeds with each line of code, giving the diagram here. You can observe what happens in working of compiler, what happens in working of interpreter. Here, compiler takes a source code, entire program code, and compile the entire code. Any errors occurs, it will show the line numbers with the line numbers. All errors are completed and that code converts it to error free, then it will go to execute. In interpreter, source code will return in this left side. The interpreter involves with this program code. Then it will take each line of code one line, and it will execute. It will convert to object code. Then it will send it to execution. The this is the interpreter. Those interpreter and compiler are totally different in each step. Then let's come to the difference of compiler and interpreter. Compiler the differences both the translator software in the form of compiler where interpreter. What will happen? Compiler input. Input, a compiler takes an entire program as its input. An interpreter takes a single line of code or a single instruction such as loop as its input. Output, it generates intermediate object code from the whole program. It does not, in an interpreter, it does not generate any intermediate object code. The next memory, in compiler requires more memory during compilation. So the compiler will take a whole program, will convert a whole program at a time. This will take more memory. In interpreter requires less memory. It will take each code of unit of code or each line of code, single instructions. It will take at a time, so it will take less memory. Then next, errors displays list of errors of a entire program with the line numbers and the errors in that line. An interpreter displays the error of a single line, single instruction in its interpreting. Thus all error also appears one line at a time. If one line is cleared, then it will go to next line. Always required, which is always required. Compilation is not required in always. Once the role of compiler is over, the compiler is no longer required to run the executable file. Always required interpreter translates and runs one instruction every time, so it is always required in memory to run the code. Workload, compilation once done stays always. Recompilation not required if the code without any change needs to run again. The same executable can be rerun without the compiler. Interpretation is required each time you have to run the code. The interpreter does not create an executable and hence it is required every time the code is to run. I said all the regarding code information, what is source code and what is translator, what is the difference between compiler and interpreter in this video. Next video we will see what is the role of operating system in running a program. Then meet us in next video. Thanks for watching. Subscribe my channel for further videos.